together for our next speaker, Mr. Rangarajan Vasudevan.
So I'm going to be talking about a very specific concept called data native. It's going to be a small presentation, but it's a new concept. So if you take away something from this talk, it's about data native. So just few slides on what the concept is, and then we'll get into an example of how this can apply from a perspective of retail banking. So a little bit about myself and what we do at the data team. So start off doing computer science from IIT 2004 through networking at PhD school, dropped out midway because I had a tiff with my advisor at that time. Then moved on to being a founding employee of a company called Aster Data Systems. So at that time we did a lot of the large-scale data science algorithms even before data science became popular as a concept. So this was back in 2006. Aster got acquired by Teradata for a whopping amount of money, and then from Teradata started to do a lot of consulting, and that's when we started to realize that the way data science or nowadays AI gets applied is itself still a mystery. To Dr. Isaac's point, a lot of the revenue is not clear, so it's up to people who are practitioners to help make it easy for enterprises to consume AI machine learning. So that's why we started the data team. This the last slide you'll see this logo, so after this it's about data native. So we are in the business to help enterprises become data driven. So we've pioneered a methodology for how do we get to operationalizing data science and delivering value for enterprises. That's called robotic data science. You can check it out on our website. But let's move on to the interesting topic for today. So data natives, spelled with an S, started as a concept late 2014, I believe. So this was an article published by a LinkedIn data scientist. She went on to do data science at Jawbone and a couple of other places as well. But she called out the fact that we are all, as consumers, data natives. And what she meant by that is, in the old school, if you were a digital native, as an example, you would expect a thermostat to be digital, and then somebody would be able to go look at the digital thermostat, look at the current meter reading, and say this is too cold in this room, right? But if you were a data native as a consumer, you would expect the thermostat to automatically adjust, right? Without having to go and physically tweak anything, right? So she made this distinction between a digital native and a data native as a consumer, or as a consumer of products and services. And that really took off like wildfire, so much so that this was one of the first data natives conference that was done. I think it was somewhere in UK, and a lot of the topics and conversations were around data science, actually, as it turned out. But if you step deeper into what she was really pointing out to, and this is my personal conception, right? I don't think it's still caught on as a concept yet, is a data native not as a consumer. I mean, consumer mindset is one piece of it, but if you really look at what data native is about, it's actually about an application or a process. Because at the end of the day, almost everything that we consume is digitally available to us. Setting aside, of course, the physical assets. So if you're going to consume digitally, can that digital consumption be made better? And the fundamental basis for data native is, yes, you can, by actually having data as a design principle. So for those who have developed software, there have been evolutions in the way architectures have evolved for software engineering over many, many years. So what we're seeing here with this data native concept is the use of data as the design principle. So one interesting article that was written by, again, a very famous AI practitioner, he called it Software 2.0. So Software 2.0 pertains to how you don't need to write code which actually codifies rules, for instance, like rules of engagement for a customer with a bank, as an example. So the traditional way of writing software would be, I'll write a whole bunch of rules, and then those rules define how a customer deals with me as a bank. Now, if I want to change something, you go back and change the rules, change the software, and so on. But in the world of Software 2.0, what he hypothesizes is, it's no longer necessary to write the rules yourself. Instead, write the code which will write the rules. So in this specific case, he talked about deep learning networks as the code that you write, and the weights that get automatically adjusted based on data become the code that the network writes. And that in turn defines all the rules of engagement for a customer with a bank. Whereas here in data native, we are expanding the concept a bit more. So for those who work with deep learning, you realize that a lot of context is missing when you engineer a deep learning network. That's because it sets aside anything related to the domain. Instead, it focuses a lot on the network and the weights attaching the networks together. Whereas in most practical enterprises, the context is everything. Right? The way a customer deals with a bank, there is a lot of context around it. So those kinds of contexts go beyond what at least he defines software 2.0 to be. That's why I believe data native is a better concept to think about. The analogy, I mean, the best way for those who are familiar with cloud, have you heard of cloud native? Anybody? Right, so very few hands. Let me give a simple example. So if you talk to somebody like Netflix, and if you tell them that I've moved my CRM application to the cloud and therefore I'm cloud native, they'll laugh at you. Right? The reason is being cloud native is more than just moving things to the cloud. It's actually fundamentally re-engineering applications to take advantage of resilience, scale, and always on availability. So that's cloud native, broadly speaking. So likewise, if you talk to one of these data native companies, again taking Netflix as an example, if you tell them I'm doing data science, I'm developing software, therefore I'm data native, again they'll laugh at you, because data native here means being able to embed those insights that you're actually operationalizing into the application itself without involving humans in the loop. So that's a critical capability. So as a concept, this becomes very powerful for various stakeholders. So very simply put, for the CXO, it will finally derive value from data. I know this is a promise that's been happening for the last 3 decades, 4 decades, I guess, but it will finally deliver value is what I strongly believe. Analytics leaders, it'll help satisfy business needs much quicker. For an engineer, it'll help write effective and efficient software. And this means no more change requests just to change a rule, having mechanisms to have data science workloads and functions be embedded natively. And for the data scientists, it's getting things done without having to translate all of this knowledge for IT to actually implement. And that's a huge problem in traditional enterprises, this dichotomy of what the business needs and versus what the IT can actually deliver. So let's take an example of what data native is from the next slide. So broadly, these are the characteristics of data native. You want always on data collection, which means every single facet of what you build as an application should monitor itself, should generate data about how it's actually doing things. So that's collection. The quality should be something that's provable. So it shouldn't just be garbage in, garbage out. Be able to actually trace what data set is coming from where. Have mechanisms of providing access to the data in a way that's easy to understand. So for instance, if you capture all of your audio logs in audio files, which nobody else can read, that's not very useful. Right? Access is that plus more, right? Intelligence, of course, a lot of emphasis on operational intelligence, business intelligence. But the final piece, which is really the killer, if you want to think about it that way, is evolution. Can the application or the process evolve by itself? Right? By monitoring itself, monitoring its data that's good quality, the context of that data, and have the mechanisms of deriving intelligence so that it evolves. Let's take an example. So we've all been through this situation before. Any recent times when your ATM card has been blocked because of wrong PIN? I had it happen 3 weeks ago. Right? So what happens when, let's say, the card gets blocked? So the example where it happened for me was landed in the airport. Uber, the driver refused to accept card. So I had to change into a cash. I didn't have cash, so went to the ATM and then card blocked. So there's a small sense of panic that starts happening. So what I then did is open up my mobile app to see whether my bank provided anything useful. What I saw was 20% off at bookmyshow.com. Not really useful for me. The panic is continuing, right? Then I called up the call center, this standard rigmarole of things. Right now, please report to us if your card is lost. Otherwise, press 1 for English, 2 for Hindi. And it's not really useful at that stage. But imagine if you were to actually collect this data in real time and had the process. Here, I'm talking about 2 different things here. The mobile application as well as the process in the call center. What if you could have this be intelligent, like that's live? So what if the mobile app, instead of, in addition to saying 20% off for book my show, also gave me a notification saying unlock card? Because I know already as a bank, right? Or if I call up the call center, the first thing that happens is I recognize the number and I say immediately, are you calling about a lock card? So imagine if you can change the experience in this particular way, it makes for a completely different kind of experience for the bank. So if you think about what is required for something like this, so in the classic world of how this is set up, right, it's usually in the form of rules, like I was talking about before. So somebody in the engineering team, in the business team, is defining rules for what kind of offers to show to customers, what kind of script to follow when somebody calls into the IVR. Now, if those rules are set with traditional mindsets, usually it's about what agenda marketing wants to push. So there is very little intelligence. So nowadays banks are talking about personalization of offers. So how do you personalize them? So one way of personalization is using a data science team. So you start to build intelligence of segments of people. Then you start to see that this segment of population is very good at absorbing these kinds of offers. So you start pushing them around, which is fine, which makes sense. Now, what if you want to do this kind of dynamic adjustments to this context of the scenario? So at this point, you start to think it's more than just the rules that you have to learn, right? You have to learn context. You have to learn ways in which the rules get applied. So in classic parlance, this would be called something like A/B testing, right? This is what many companies have done, eBay, Netflix, and so on and so forth. They've done it very successfully. But imagine being able to do A/B testing on customers with multiple different channels of interaction. It becomes quite a bit of a challenge. Now, let's set that A/B testing piece aside. We'll come back to it a little later. If you look at what typically happens in the minds of the data scientists when they come up with the final set of offers to give, it's actually fundamentally analysis of a lot of data. Where is the data coming from? It's actually coming from the same applications and processes. Nothing new, really. There's some bit of external data, of course, on customer behavioral patterns or salary information and so on. So if you could get a machine to do that, right? If you could get a machine to look at that data and come up with, these are the 5 rules that I really need, then it becomes really powerful, because now the application or the process can invoke that learning algorithm dynamically, so that what comes out of it as outputs becomes something that you immediately surface, right? So that's the simplest way to think about data native. But a lot of caveats here, a lot of issues like governance, lineage, all of those will have to be taken into consideration. Let's build this out a bit more. So now, if the same situation, ATM card blocked, there's a user who calls in. When the user calls in, there is existing information about the user that you already built up as a bank. So you know the user is 52 years old, bunch of activities. So let's assume one of the things that the user is doing right now is EMI payments. And also, he's applied for a loan for his car. And he's actually looking to track the loan status as part of his mobile application. So that's something that he normally does. We know that this user is using basic phone, a feature phone, not a smartphone. And if you look at the history of how he's interacted with the bank, there is typically a common set of activities that he does on the call, with the call center: balance check, loan request, EMI update. Now, from a bank perspective, of course, the bank has a bunch of things to push: products, services, various ways in which the customer can be made to be more sticky. Now, in this context of this interaction, can the context really bubble up as something that's dynamic? So, as it turns out, the current context is card block, and that's a new card block that's a new activity that's actually coming in. And can this bubble up for the banking institution internally to say that the card block service is really what's important? Now, at this stage, let's say that you've successfully done this. How do you communicate to the user, right? Let's say the user is actually calling in. So you would be able to change the script dynamically and say that this is what you actually have to do. Now, if you look at the change of script, it's not just the fact that card block service is there, but also how do you address it in a way that's understandable for the customer, which means language of communication, which means the kind of words that you use, and so on. So here, it's a feature phone user, somebody who keeps calling all the time. So it makes sense to say, are you calling about your card block? But let's assume it's a different type of user, right? So here we're talking about a user who's much younger, right? Who's using a smartphone, typically doesn't call the bank at all. It does almost all of other things by using digital channels. So for this kind of a user, the kind of interaction that's required is very different. So why does this matter? It matters because the bank could actually decide to intervene. Like instead of the user calling up, the bank already has the data. So that's the next step. So why doesn't the bank actually call up the user directly instead of waiting for the user to call, but is calling the right thing to do, right? So in this case, the bank could look at this user profile and say that the user is actually using a smartphone and prefers mobile or digital channels for engagement. So now the question is, should the bank call to say, look, I know your card is blocked? Would that be intrusion of privacy? So that's an open question, right? You could argue one way or the other. But what if I showed you this kind of a screen, right? Which means that the person is actually not online, right? You don't see 3G or 4G there. It's connected on the mobile. So if you have that piece of information that's live, probably it's better to actually call and then say, look, I know you don't prefer to be called at all, but we thought that your card might be lost. Imagine that kind of a customer experience versus what we saw before. Now imagine all of this happening automatically. That's the power of data native. And it's really, really powerful. But let's take a more complex example, because this is quite simple. It's easy for us to say three times false attempts that you want to call. Let's take the example of journeys. So what we're saying here is customers who are logging in, a whole bunch of them check balance, they wanted to actually do some fund transfers, and then when they add beneficiary, there's a huge drop-off that happens there before they are able to complete the payment. Now, if this kind of a situation happens for a bank, it's quite serious because they want to understand why is that drop-off happening really. Now, a typical way in which a bank would approach this is, like, why is this particular drop-off happening? Which could be interesting or not interesting. Let's assume it's interesting. If it's interesting, then should we help or not? Help could mean intervention, could mean calling, could mean making things more efficient, better, and so on. Variety of ways in which help can happen. And the third piece is, if we have to help, how do we help? Okay. If we have to help, how do we help? So here, let's start looking at the why question. The why question is usually answered by a data scientist. So this is the standard process. You come up with a hypothesis, figure out what works, what doesn't work. I think it comes back to the question somebody was asking before. So how do we figure out why, the reasons behind a certain type of behavior? So let's assume that a data scientist goes and looks at this. There is no prior information about this kind of behavior. So we use clustering unsupervised techniques and we come up with these kinds of clusters. And we start to see that there's one cluster of users who actually end up churning. Churning meaning different things, right? Could be lesser activity with the bank after that point in time, or could mean that they completely take away the money as well, right? So from the point that they drop off, right, a majority of them churn, a good chunk of them actually remain with the bank, non-churners. Now it starts to get interesting. So the why question could be answered by saying, look, there are a bunch of people who churn after this kind of an activity or this kind of a drop off. So maybe it's time for us to do something about this. Let's start helping out. Now let's dig deeper into this churners, right, or non-churners. So what we start seeing here is a typical pattern of activity that a data scientist would do, or data science team would do. So for all the people who drop off, it turns out that two variables are very important. One is the location where they are, and second is the digitally active engagement that they have with the bank. So a digitally active engagement would be they use mobile phones, net banking, and so on. But somebody who's not digitally active is just calling up the bank all the time or walking into the branch. So turns out, for those who are in Singapore, being digitally active or not is having a dramatic effect. So that's what the data science team finds out. Whereas in India, it doesn't matter that much. So now you have something very concrete. The data science team has actually unearthed this piece of information. So how do we deal with this now? So what the bank would now like to do is understand whether correlation is causation. Right? So we know digitally active in Singapore versus non-active in Singapore makes a big difference. But is that causative for the churning behavior? Let's say there's an experiment that's run. You have to do a bunch of different experiments here. Here's where A/B testing plays a role. And then you conclude some pieces of insight from it. It could run a month, it could run a quarter, whatever it is. So at that point, you've built up enough causative knowledge that it's time to intervene. So now if you ask this question, to help or not to help, it makes a lot of sense to help. But how do we help? Right? For a person who's making this judgment, right, you would never ask the Singaporean resident to move to India. It just doesn't make sense. Whereas from a data science perspective, that's variable 1, variable 2. Variable 1 is fantastic if you move over. So clearly there's a lot of context. But if you ask them to download a mobile app, that makes a lot of sense. And then you start to get them engaged digitally. This kind of a flow, if you think about automating this, that's a lot more challenging. And here's where again data native plays a role, because it's the context with which the interaction happens. So the context of location being something that's an expensive value proposition, the context of something that's easy to engage with, the fact that it's a digital channel, all of these have to be taken into account. And we take these for granted when we set up data science experiments and actually try to operationalize it. But for an application or process to take these kinds of decisions itself is also part of the data native paradigm. So what I wanted to stop with here is data native, if you can spend a bit of time thinking about it and what the implications are for how you engineer applications and processes. I think it will definitely be the way most of all the digital services and products that we consume will move towards this. But some enterprises are farther ahead, like the Netflix and the Facebooks and LinkedIn's of the world. Thanks. That's all I have.
So we're going to do a short Q&A once again, up to 3 questions. That's what we'll give.
So really interesting way that you have put up this entire data native idea. Just one question here. So in terms of, I think you described a couple of flows here in which such an use of data could be put to real benefits in terms of increasing customer experience and other use cases. But as a process, how do you really start identifying or start putting this into action in terms of getting to this kind of a flow design? So you mentioned some way of automatically being able to identify, and maybe some of the ways we generally do in industry is to have a deliberation, get a team of business people and all the technical folks and see if such kind of use cases can be done or not. But how do I do that the automatic way or doing it at scale? Let's say identifying 10 or 15 such flows and then building a data strategy around that.
Yeah, very good question. I think there are 2 pieces of it. One is there is no getting away from the fact that you would still need that coterie of people, right? That multidisciplinary people that Dr. Isaac was also talking about to actually be able to ideate. That's definitely required. But the second piece of it is, if you look at specific areas within which you want to do this, right? Like for instance, looking at all the ways in which customers interact with the bank, that is actually a tractable problem which can be solved using data science itself. So you apply data science itself to figure out what needs to be solved and then take it forward from there. So I guess you could use automation in those kinds of situations, but you're not getting away from the fact that you need domain experts to help you out. There are methodologies you can follow. We have done some work ourselves as well, but those are consulting frameworks. So there's one example called Cunefin framework. It's spelled as CYNEFIN. So that's a fantastic framework to think about at a very broad level on how these kinds of problem statements break down and how much of it is tractable with data alone. Because in many cases, it's not a data problem at all. In many cases, it's just a process issue, in which case any amount of this kind of automation is not going to help. So that framework actually allows you to come up with some way of measuring it.
Hi, I'm Rajesh Sule. I'm from digital marketing. What I'm getting here is, if I were to kind of take that question and what you have put up there, is there a gap of language between the business head and the data scientist? Because what you brought about vividly kind of, I can now start thinking about 100 other things that can help me if I was a business head to kind of start, looking at implications. And I think so one of the problems that is happening with the business heads is that when they talk to the AI guys or the ML guys or the data scientists, they are not able to kind of vividly bring about what can be done. Therefore, it cannot help the business guy really say, what can I solve? But one big question that is happening is that I don't think the business guys are becoming more vibrant enough to say what kind of problem should be given that can help get me solutions. So my feeling here is that there needs to be some way that a language needs to be spoken between the two that helps bring about such kind of solutions.
It's a very good point. It's something that I think the industry has been grappling with for ever since the data science evolution has started. I think some part of the answer lies in technology. I mean, not all. If you have the right foundational layer, by that I mean the right set of processes in terms of technology, in terms of use of technology, and the technological architecture itself, the platform itself, then a lot of this dissonance that usually sets in between business and IT or business and data science teams typically ends up being lesser. But again, you're not getting away from the fact that domain expertise is absolutely critical, right? That's why in many cases we've seen data science teams be embedded or working very closely with the business as opposed to sitting inside IT organizations which are siloed. So I think part of the answer is technology, part of the answer is you have to get people to talk to each other.
Is it the data native is more on the context of the data rather than the way the data is generated, rather than how you process it?
It's in fact all of those 5 things I talked about. Okay, it's going to take too much time for me to scroll all the way back. It's all the 5 things: collection, contextualization, making sense of it in terms of quality, in terms of intelligence, and then applying it in action.
And again, that will bias of the data which is generated out of that intelligence.
It will definitely generate more data. Whether it will bias or not can be programmed into it.
Example, if I'm the one who watches more mystery movies on the Netflix, I get recommendations based on that. And I miss out the romantic movies which may be coming up.
Certainly, yeah.
So that kind of, the reason I ask is more of the contextual side is that your context drive data and drive back again to the context.
Certainly, yeah. So these biases have to be consciously watched out against. Again, I think coming back to Dr. Isaac's presentation, there is a virtuous cycle of data creation and therefore business creation, but there are challenges with respect to use of data science anyway. It doesn't matter whether you use automated methods or you do manual methods. Biases are there. I believe as a data scientist myself that with technology, again, you can engineer control systems which watch against biases as well. That's also possible.